How do scientists come up with names for chemicals like sodium phosphite and CaO2? There's a simple way to name chemicals that I can teach you. First, you have to separate chemicals into ionic compounds and covalent compounds. Ionic compounds are formed with a metal cation and a non-metal anion. Covalent compounds are formed with a non-metal and a non-metal. Let's look at ionic compounds first. Say we wanted to combine potassium and oxygen. The first step is to figure out the charges of each element. Since potassium is an alkali metal and in the first group of the periodic table, it is going to have one valence electron. Every element wants to become stable by either having 0 valence electrons or 8 valence electrons. To become stable, the potassium atom is going to lose that 1 valence electron, giving a charge of 1 plus, or K plus. Now let's look at oxygen. It is in the 6th group of the periodic table and is going to have 6 valence electrons. To become stable, an atom of oxygen is going to gain 2 electrons, giving a charge of 2 minus, or O2 minus. So we have positive potassium cations and negative oxygen anions. Their opposite charges attract each other, forming the ionic compound. All the ionic compounds blob together to form what is called a crystal lattice. Each element occurs in a certain ratio within the crystal lattice. We can find this from looking at the charges of the elements. So we need to make the charges of the elements add up to 0. So we have 1 plus charge on the potassium and 2 negative charge on the oxygen. These add up to 1 or negative 1. But we need a 0 charge, so we're going to need 1 more potassium atom to make up for the 2 negative charge on the oxygen. So if there is 2 potassium atoms for every oxygen atom, we can write the formula of this ionic compound as K2O. A simple shortcut to take when finding the ratios of the elements is just to take the charges of each element and switch them to the other element. When you're writing the formula, the metal always goes first, followed by the non-metal. If there are multiples of any atom, then you write it as a subscript to the right of that element. But what is the name of this element? First say the metal, potassium, then you say the non-metal, but with the suffix "ide". So oxygen with the suffix "ide" would be oxide. So we can name this element potassium oxide. I know that may be confusing, so let's do one more example of a simple ionic compound. Let's combine calcium and sulfur. Calcium is in the 2nd group, so it gives it a 2 plus charge. Sulfur is in the 6th group, so it has a 2 negative charge. The charges add up to 0, so there is 2 calcium cations for every 2 sulfur anions. However, this ratio can be reduced to 1 for every 1. So the formula is just written as CAS. You always simplify the ratios of ionic compounds if possible. So to name this compound, we say the metal, calcium, and then the non-metal with the "ide" suffix at the end, sulfide. If a metal has more than 1 charge, indicate which charge it is by writing a Roman numeral next to the element in parentheses. For example, if the compound was iron fluoride, you would indicate iron's charge of either 2 or 3 next to it in parentheses. These are just binary compounds, meaning only 2 elements. But what if we combined a metal with a polyatomic ion? The procedure is very similar. Let's try magnesium and ammonium. Magnesium has a 2 plus charge, and you should know that ammonium has a 1 plus charge. We could take a shortcut and just switch the charges of magnesium and ammonium and write them as subscripts. But since ammonium was a polyatomic ion, we're going to need to put parentheses around it and then how many of them there are. So there's 1 magnesium, so you write Mg, and there are 2 ammoniums, so you write NH4 in parentheses, and then a 2. To name the compound, you say the metal, magnesium, and then you just say the polyatomic ion, ammonium. So we have magnesium, ammonium. Pretty simple. Now that we have ionic compounds out of the way, we can move on to covalent compounds. One note before we start, covalent compounds form molecules, not crystal lattices. So there's no ratios for the elements. The number you put beside each element is really the number of atoms that are in one molecule. So let's say we're combining oxygen and chlorine. Writing the formula for covalent compounds is exactly the same as writing ionic compounds. The element the farthest left on the periodic table is written first. Like with ionic compounds, the first step is to find the charges. So oxygen has a 2 minus charge, and chlorine has a 1 minus charge. Take a shortcut and write out OCl2. Now what's the name of this compound? This process is slightly different. First, you must know the prefixes for the amount of each element that occurs. 1 is mono, 2-di, 3-tri, 4-tetra, etc., etc. These prefixes go before each element to say how many of them there are. The only time you don't use a prefix is when there's only one of the first element. So there's one oxygen. Since it's the first element, we don't need to put the mono in front of it, so we just write oxygen. There are 2 chlorine atoms, so you have to put the di prefix in front, and we also must put the ide suffix at the end, dichloride. So the full name of this compound is oxygen dichloride. Don't forget that the last element always needs the ide suffix. Let's do one more example of covalent compounds. We're going to combine phosphorus and sulfur. So phosphorus has a 3- charge, and sulfur has a 2- charge. Swap the charges and turn them into subscripts, and we have P2S3. The prefix for 2 is di, so the first element is diphosphorus. The prefix for 3 is tri, so next is trisulfide. So the name of this compound is diphosphorus trisulfide. That's pretty much all you need to know for chemical nomenclature. I'm happy I could help you out, and hopefully you have a better understanding for it.